Hey y'all, welcome to my channel Land Before Time, with your host Littlefit. If you didn't get that reference, you probably grew up on Dinosaur Train. Either way, welcome aboard. Today we're going to cover k closest points to the origin. Given an array of points where points i equals xi, yi represents a point on the xy plane and an integer k, return k closest points to the origin, 0, 0. The distance between the 2 points on the xy plane is the Euclidean distance. You may return the answer in any order. The answer is guaranteed to be unique, except for the order that it's in. Before we begin, if you don't have a system that's giving you the results you desire, I highly recommend checking out my 5-step guide to your Leetcode enlightenment. The link will be in the description below. Also, there's going to be a card somewhere. Now, let's jump into solving k closest points to the origin. Alright, so we know that the goal for this is going to be return k closest points to the origin. Luckily for most of us, we didn't have to spend time digging into Amazon's Glacier deep archive storage in order to remember what the Euclidean formula is. With that said, let's move on to asking more clarifying questions. We need to know what the constraints on our inputs will be. So let's go ahead and scroll down to Leetcode, and we can see that our point's length must be greater than or equal to 1. And same thing for our k. Next we want to ask is whether or not output order matters. If we scroll back up, we can see that output order does not matter over here. So any order. And similarly, we want to know whether or not the Euclidean distances can be unique or not. And we can see right here that it will be unique. With that said, let's move on to constructing some examples and brainstorming some ideas to solve this. Let's go ahead and take the first Leetcode example that we see here. We know our points is going to be 1, 3, negative 2, 2. The k is equal to 1, and our output will eventually be negative 2, 2, only because this is smaller than this one. And we only want one element here. Since we have 30 minutes in an interview, let's not try to attempt to do math on the fly. Let's be honest, those skills were left in high school. Let's make some inputs to demonstrate how our heap would function. Let's use something like 4, 3, 2, 1, and k is equal to 2. Since we know that we've decided to go ahead and use a min heap for this, we are going to be saying something like 1, 2, 3, and 4. We know that we can go ahead and just remove 1 and 2 from the queue, and we'll end up with our output being something like 1 and 2. As we can see here, as we're adding these to a min heap, this is going to take O of n runtime in order to add each element to the heap, and it's also going to take O of n space time in order to add each element to the heap. Let's take a moment to gather our thoughts and write out a blueprint. Go through the list, add the item to the min heap, and remove the top k from our min heap and transfer it to an output array. With that said, it's time to code. Mishaps along the way, but we have a starting point now. And the solution is currently an n log n time, and we definitely can do better. So tune in next week to see how we transform this existing solution into a more optimized solution. With that said, happy Leetcoding. If you found this video helpful, give it a like, comment, share, and subscribe. And see you in the next one.